Hi everyone! All right, here's your quick video for adding and subtracting numbers in scientific notation. Now technically I'm recording this a day early, but whatever. So I'm just gonna walk you through a few examples that we will have gone over in class today, just in case if it was too fast or it was just too much, you have something to look back upon. All right, so let's take a look at example number 1. Now, we've got both numbers in scientific notation, and we want our final answer, our sum, to also be written properly in scientific notation. Before you can do anything, I need you to look at your exponents here. I see that I've got a 6 and I have a 6. Well, that's actually great because that means same exponents, I can just go ahead and add or subtract whenever the problem tells you those target numbers, and then just keep that power of 10 with the exponent. Let me show you what I'm talking about. So I've got 3 and 4.5. Okay, well, I know that 4.5 plus 3 is just 7.5, and hopefully you did that in your head. So you've got 7.5, and then it's just times 10 to the 6th power. And that's your final answer. So it's nice when you have the same exponents because you can just add or subtract those first numbers and then just keep this power of 10. You just need to make sure that your final answer is written properly in scientific notation. If it was like 85 times 10 to the 6th, that's a no-go because that number is too big. Okay, example 2 here. Looks very similar, but when you're examining those exponents, you see that you have a 6 and you have a 5. That tells you that you need to really quick convert it to standard form, add them, and then convert back to scientific, which is why we spend so much time converting between scientific and standard. So if I'm converting 3 times 10 to the 6th power to standard form, remember my decimal starts here. This tells me to go to the right 6 times. 1, 2, 3, 4, 5, 6. Fill in with zeros. And then as you've seen me just count back so that you have the commas in there. So this number is 3 million. Then come over here and convert this number to standard. Okay, again, it's 4.5 times 10 to the 5th. I'm making a large number that's greater than 1. And I'm going to take this and go 1, 2, 3, 4, 5. And then go fill in with your commas again, just so you have a better understanding, like, okay, that number is 450,000. Then just add your two numbers. If I've got 3 million plus 450,000, your sum is just 3,450,000. You just add them together. The thing is, though, I need your answer converted back to scientific notation. So right now this is in standard. I want it in scientific. Your decimal's right here. So you're just going to move it until you can create a number between 1 and 10. So it's going to go 1, 2, 3, 4, 5, 6. So, okay, I guess I'm going to write over here. So I know it'll be times 10 to the 6th power, and my new starting number is 3.45. And that's your final answer in scientific notation. So look in the first example, we had the same exponent, so life was easy, and we could just add these two numbers and just keep that power of 10 with the exponent, as long as your final sum or difference is properly written in scientific. In this one, because you had different exponents there, you had to convert both to standard, add them, convert back to scientific. Let's look at one more, and let's look at ones with negative exponents, because that's always fun. Okay, take a look. I've got my first number, my second number. As soon as you see that you've got negative exponents, actually, sorry, scratch that. They're different exponents. You know that you're going to convert to standard, subtract based on this problem, and then convert back. So if I'm converting this number, I've got 7.5, and that negative 2 tells me that I'm creating a small number, a number that's less than 1. Therefore, I'm moving my decimal left once, twice. And that gives me the number 0.075, okay, or 75 thousandths. Over here, I've got 2.2 times 10 to the 3rd. Take my decimal, go 1, 2, 3, and my number is 0.0022. Okay, I'm going to delete this just for now. I mean, I know you don't care, but I'm talking to myself. Now you're going to go ahead and subtract these numbers. Remember though, when you subtract decimals, Line up your decimals or your 5th and 6th grade teachers are going to cry. And remember, when you have a problem like this, if you have this empty space, you know that you're adding in a 0. And then, my friends, you're literally just going through and you're just subtracting over here. Okay. Welcome back to it. We have to borrow. 10 minus 2 gives us 8. 4 minus 2 is 2. We still have a 7. 0. That answer, though, isn't cool. Like, I don't want it in standard. I need it back in scientific notation. Okay. So you're going to take your decimal and go once, twice. Here I am. And I've got 7.28 times 10 to the negative 2 power. Negative because it's a number smaller than 1. Okay. And I moved it twice there. So just to sum up, when you're adding and subtracting numbers in scientific notation, sometimes it's pretty simple. Like if you have the same exponent here, that's great. That's awesome because you can just add or subtract those first numbers and keep that power of 10 with the exponent as long as this first number is between 1 and 10. Okay, if you had something like 750, no, you'd have to convert that. But if it's less than 10, greater than 1, you're good to go. When you've got exponents that are different, just convert them to standard, add or subtract whatever the problem tells you, convert back to scientific. Okay, and that's exactly what we did here. When you have those negative exponents, though, you have to be aware you're going to be creating decimals. And when you add or subtract, please line up your decimals. Just please do it. And then convert back to scientific. All right, my friends, I think that that's pretty much all I have for you. So thank you so much for tuning in. Welcome back to the channel. Like, subscribe, hit that button. That's what they say, like famous people on YouTube, right? Go. All right, bye, guys. Thanks.